Okay, so in this video clip, we are going to address this problem. Download daily data from Yahoo Finance for 10 stocks for a 1-year period. Estimate the daily returns using annual observations. Estimate the variance covariance matrix of the 10 asset portfolio. And verify the variance covariance matrix estimation using R, Python, Excel, and Google Sheets. So the approach we're going to follow here is basically follow an approach suggested by Simon Benninga, where we're going to take the stock prices for, in our case, we're going to extend this to 10 assets. We're not going to use annual data. We're going to use daily data for 1 year. We're going to take the stock prices and convert into returns using log difference. And then we're going to convert that into excess returns by subtracting away the average return from the daily return. And then finally, using matrix operations in Excel, estimate the variance covariance matrix. Now, we're going to initially, to deal with the problem we have at hand, we're going to use Python to import in the price data, so the stock price data using Y Finance package, and then run the estimation in Python, then run it in R, then verify in a spreadsheet. Okay, so that's already worked through. We'll just take a look at the approach that we have here. So basically, we're going to start by a pip install Y Finance. Now that's the link to that, right? If you want to copy data into a Python notebook, we're using Google Colab here, and we can use this package, the Y Finance package, and then we'll do a pip install Y Finance. Now that's a simple enough process in Google Colab. All we basically do is to write in this exclamation pip install Y Finance, and then the rest is done. That might take a moment. Then we have to pick out variance stocks, so we get the ticker values for the stocks we want. In this case, we're going to use Apple, Walmart, IBM. I think this is Micron, Boeing, Facebook, Amazon, Netflix, Google, Microsoft, right? And then we're going to import in. So if we execute this, it will load in directly from Yahoo Finance rather than import in each stock individually. We'll import in using the Y Finance package, stock prices going from 2020, the 1st of January, to 2021, a year later, exactly the 1st of January as well. We're going to take the adjusted close price. There's different time series available for each stock. We'll go with, just for convenience, we'll take adjusted close price. And then we can print off, if you like, we can print off the first 10, just to take a look at what's available, right? How we would eyeball that data. And again, but there's more observations here. There's a full year of daily prices, and you can see that it's daily data. So the 2nd, the 3rd, the 6th, the 7th, the 8th, the 9th, the 10th. So that's a 5-day run, then a weekend, and we start off again. So this runs for the entire year. We could look at the tail data to see, let's take the final 10 rows. Okay, so the final rows bring us up to the 31st of the 12th, right? So we get the full year of data going from 21st of January to the 31st of December of 2020. Okay, so that's daily data then. Now, following the approach suggested by Simon Benninga, the approach we use here in estimating the variance covariance matrix. We had our price data, and then we converted that to log difference to get the return, the daily return. And then we directly estimate out then a variance covariance. So that'll be the approach here we'll adopt in the Python notebook in Google Colab. Okay, so we run the estimation then to get the log difference. Again, we can take a look at the first few rows. Why none here? Well, when you estimate daily returns, you miss the first row. So this is January 3rd, 94. We miss the first row here. So we can't take the log difference from the year before because we don't have the previous year. Okay, so there is going to be a row then that falls out of our data set, just purely estimating the returns. Okay, so we get that these cells are not populated. That's fine. That's what we would expect. And then just to see what's in at the end of that data set, we can put in here tail, and that'll bring us up to the 31st of December 2020. Okay, so that's fine. And then it's a very straightforward exercise to estimate the variance covariance matrix. We just say take the returns. Now we refer to this as returns. Once we took the data in, that object we created for the stock price data that we have here, we just basically called it data. And then we took that data, we took the log difference, got the returns, and then we estimated the variance covariance matrix of those returns. So this object that was created here, the log difference, we referred to it as returns, and then we took the variance covariance matrix of the returns object, and we created a new object covariance matrix, which we output here. Okay, and that is the variance covariance matrix. Now, why are we interested in variance covariance matrices with stock prices? It's just basically a building brick then for a lot of risk analysis, in particular valued risk. And I have a couple of video clips set up to do that, and I'll leave a link below where you can follow that. But the variance covariance matrix for stock price returns is something that we use to develop a lot of risk modeling, right? And it's kind of the basis of a lot of the analysis that we employ. Now, not happy that just we've worked out this variance covariance with Python. We'd like to verify using R, and I've left some code up on a portal, and I'll leave a link also to that hyperlink below the video, bringing you to Vinegar Hill Finance. So we want to estimate. Now, the first thing we do here is before we finish in the Python notebook, we just got the average returns and we report those out. So that's innocent. And also we import in matplotlib, and then we plot out the returns for the data. And you can see Walmart seems to be a little bit less variable than other ones. And we can take maybe a bigger view, augment the scale of that. And that's maybe a useful visualization of the stock daily returns, and we can see the date, and we can see the range of values here. So 0.2 on some days, it's very exceptional. And then there's very dramatic drops here of negative, probably 0.3. So a lot of volatility for some stocks in 2020. Okay. Now, if I want to then make use of that data and I want to write out, let's see, the data file where I have contained that object that contains each of these individual stock price series, I can invoke the data to CSV, but I'd like to know where that is going, and a check to see just where your files are being read in from. So if you create a data file and you want to write it out, or you want to read in a data file, you would like to see the directory where that is. So if you come over here to the icons and click on the files icon on the side, and if you go into content, the content folder, this is where data is being read in and out. Now at the moment, we don't have any data there. We do have sample data, but that's separate and independent. So that's pre-written data that's just sitting there. But if I want to write out the stock price data, if I want to take the data, that stock price data that we imported in using the Y Finance package, then we take the name of the object and we say to underscore CSV and then give it a name. And when we run that or execute that, then we will find over here that that data will appear in our content folder. Now there's a little bit of latency, but eventually it does turn up, and it's turned up. And just notice, verify that it is stock price of CSV, and we can eyeball that. If we double click here, we can come over here and just view our data and verify, look, started in 2020, stock prices. Interestingly enough, everything is organized here alphabetically, right? That's convenient, and we might maintain that order then as we proceed through the estimations, right? So the way that data goes in, even though we hadn't anticipated, we had basically the ordering of our data was not initially alphabetically, but once it goes in, it's ordered alphabetically. Okay, so just that's somewhat convenient. Okay, so we've read that in. Now we can activate our cells in Google Colab. So this command, load extension rpy to .ipython. Once we run that, that means we can run our code in the Python notebook, and we'll load into this environment then the stock price data. Right, so let's run that, and of course we're printing out, and it's a little bit more clunky because it's reporting everything out. And that can be useful sometimes when you have a slightly smaller data set. But we can eyeball everything that's there. And just notice that the ordering here also then has to be alphabetical as well, since we took the data from here. Okay. And then we come down and we want to do the same steps. We want to estimate the returns for the stock. So in R here, to convert each of the stock price series into return series, we just take the log difference, identify the name of the data we're reading in, and then the column that's relevant, and we run the data. So each subsequent stock price is going to be converted from the stock price, and we create a new return series, and we're going to refer that to as being AAPL with lowercase r. So we take the stock price data, we now have return data, we created this return data, and I'm going to do that for each of the stock prices we have here. So let's, don't have to run that cell, let's do it for each. So we took Walmart, IBM, MU, Boeing, so on, and we've estimated returns for each of those. And then we take the data, and if I don't order them here alphabetically, it'll read in the order that I present. So I've set these up that they are alphabetically ordered. And then we create this object portfolio R with the returns. And then we can print out the returns if you like. And then we've taken the covariance of the portfolio.r. So basically that data frame, we've converted the returns into the variance covariance. Now we can do a little check here. Let's just compare the output that we have here against what we previously had estimated. Let's just push that, resize that, and this is a check, if you like, to make sure that the Python and R code is producing variance covariance matrix that are the same. So let's just take a look here. We look at the variance of the apple, and we can see 000866, same value here for Amazon, and Apple, the covariance is 0005. Okay, now got to be noted here, what's on the diagonal is the variance and off diagonal is the covariance. But each of the values we can observe, for instance, this, the variance of Walmart, come down here, 000386, same value here. Covariance between Walmart and Amazon, 00214, right? And come down here, 000214. So the covariance between Walmart and Amazon, 000214. Again, it's the variance covariance of the returns, right? And we're using the log returns, which would be approximately the same as the percentage returns, right? Especially for small changes in the stock price. Now, okay, so we've our stock price data, and we have loaded here into this environment. Next step, consistent with what we've looked for in terms of overall thinking here, can we verify these results in R and Python? Well, we've done that, and we'd like just to verify using this approach suggested by Simon Beninga, using these steps here, going through a very manual setting out of the stock prices, converting to the log returns, converting then into excess returns, and then applying matrix operations in Excel. Can we verify that we're getting the same variance covariance matrix? Okay, so first thing we should do here is import in the data, and then we'll set out the stock prices. We'll follow the approach suggested by Simon, convert our data into return data. So the stock prices get converted into return data, and then convert our returns into excess returns, and then output using matrix operations in Excel, the variance covariance matrix, right? Okay, so first thing we've got to do is to go back into our Google Colab, and let's just download the data that we have here. To download it, if we double click, we can observe what's there. To download that is simple enough. We come here, look for those three dots, and just download. And that will then come into our downloads. I'll open it up, and we'll just do a basic copy here of the data. So I'll copy everything that's here, and we'll just come down. Let's take it all. So I'll just grab what's here, copy, bring it down, and we have a little bit less than about 252 observations, 253 excluding the labels. Okay, and we go into then our spreadsheet, and we'll paste in our data, right? So that's gone in, and maybe we'll just redimension a little bit the first column so we can see the dates a little bit better. Okay, now I've done the basic shell here, and the dates have already been programmed in, but let's just take the data that we have here, and we'll copy it. I've already copied in the labels, So they're pre-placed, and I'll just copy the data here. Right. So we have basically, what do we have here? We just have the prices of the stocks, the daily stock prices for each of these stocks over the period. And we can, the date, we can leave here, but if we follow the approach suggested by Simon, we take the stock price data and then we estimate, take the stock price data and then convert that into log returns. So to estimate the log returns then, it's just simply the log difference between, let's say, today's stock price and yesterday's stock price. Okay. Now, I always need a preceding cell. So if I try to run that with the period before, obviously we're not going to get a log difference for the day before. So we lose a row, right? We lose a row. And then just to note, we can pull this across and we estimate the log difference for each of the stock prices. And then we can drag it down for the full period. And so we estimate then daily log returns for each of the stocks. Okay, and you can note here, yeah, this return here is consistent with the log difference of these two stock prices. Now to take the data, maybe it's interesting just to have it as an index beside our matrix. So we can just copy that and paste those values in, but it's not necessary, but it probably is useful to note that we did lose one row in running this estimation. Okay, the next step then, following again from Simon's approach, is we have to estimate the excess returns. And the excess returns is just basically we take the return, the log difference return, and subtract the average of those returns. So we have to take each of the returns, and then we take the average. And then to get the excess returns, we subtract each daily return from the average return over the period. That produces the excess returns, and we'll use that as an input to estimate the variance covariance. Okay, so our next step then is to take the average equal to average of what? Average to the daily returns over the period of the year, right? That's what we have here. And let's hit return, and then let's drag that over. Okay, so we have the daily returns, average returns for Amazon, average returns for Boeing, average daily returns for Facebook, and finally average returns here for Walmart, right? Okay, next thing we need to do is estimate the excess returns. So basically, I want to take this value and subtract away the average, and that produces the excess return. Okay, so let's just put an equal sign here, equal to the daily return on this date minus the average for that stock. Now, notice that I have $1 sign here, which means we're going to lock the cell reference to row 2. But that means when I pull across, when I drag that cell across here, right, there is some, I can get the difference then, let's say for Facebook, Amazon here, the difference between the average and the daily return. The average return, the daily return. And likewise, for this one, it permitted me to drag across, and each time it's allowing me to subtract the average from the daily return. Now, when I drag down that cell, it is locked in position row 2 because I put this dollar sign in front of 2. So that cell referencing means that I can, as I adjust the cell, it will refer back to the average returns for each of the stocks. So if it's the Amazon, I can subtract from the average return from Amazon, but I'm still on row 2. So I can basically pull each of these down. Each column simultaneously can be dragged down, and we're subtracting the return from the average returns for each of the stocks. Because there's a $sign in front of the 2, then we're locked into row 2. Just to take a look at that, just take it randomly here. Notice that it's the daily return, log difference return, and we're subtracting the average returns. Okay, so that's in place. And then again, following Simon, last step here in the process is to run a matrix operation. Basically, we want to take the transpose of this excess returns multiplied by the matrix itself, divide by, we'll count here, it's when we say 10, it's actually, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I'm doing is I'm taking 11, subtracting 1, and that's producing 10 here, right? And we need to do that in our estimation for the variance covariance matrix of the return. So I have to count the number of cells and subtract 1. In other words, it's n minus 1, right? We're using n minus 1 here. Okay, and we can accomplish that. It's pre-written. So basically we can say equal to, and we're taking the transpose of this excess returns matrix, multiplying it by itself, and then dividing by the count. We're counting the number of cells here all the way down, and we subtract 1. So it's actually n minus 1, right? In the what's highlighted here in red, we're counting the number of cells and then subtracting 1, so we get n minus 1. Now, before, in older versions of Excel, you had to hold down Control Alt Shift Control Enter, Shift Control Enter. But here we just have to hit Return, and it'll populate the full 10 by 10 matrix. And basically, we can copy this, and we can paste, Control V, and then we can paste special, and we can do a transpose on that as well. So if we look for transpose, right, transpose it, we have our variance covariance matrix for a 10 asset portfolio. And can we verify the results against the Python notebook, for instance, which we've already checked against R? Okay, let's go back into our Python notebook. Let's observe the values we had obtained here for the variance covariance matrix of the returns, right? Let's go back into Excel, and we can just put underneath, and we can make the comparison. Or more simply, what we might do is take what we have here and do just snip, and then new. And we might just take everything in the cell, we'll copy, and then go back into Excel, and we'll make the comparison, paste. Okay, now what we should observe is what we got in our Python notebook should be exactly the same as what we have in our Excel. So let's just check apple against apple, the variance, in fact, the diagonal values. If we take these diagonals, there are variances, right? All of these are variances. And when we compare, right, the variance on Amazon 000586, 000586, the variance for Boeing is 003, and so on. What about the covariance? So if we go off diagonal, the covariance between Apple and Walmart, 000313, 000313, the covariance between Netflix and Walmart 0,00257, and likewise we have here 0,00257. Okay, so this is a basic setup in Excel, and the commands in Google Sheet are the same. One of the beautiful things about Google Sheets and Excel is that it's the same, virtually very similar type operators, and the formula work. Much of it is consistent, and we can use exactly the same syntax, right, when estimating the log returns, when estimating basic operations, taking the average. It's the same in Google Sheet. And Google Sheet is quite powerful, especially when linking in for APIs. And so this, in terms of solving the problem here, it's trivial then to go between Excel and Google Sheet. But Google Sheet offers some benefits in terms of sharing, collaborating, right, and is worth considering. Okay, so basically what we've done here is we've set up in our estimation, we want to estimate the variance covariance matrix for a 10 asset portfolio. We had to import the price data in, which we obtained using the Y Finance package. We observed or eyeballed that data. We estimated the log returns. We outputted the variance covariance matrix. We replicated that estimation in R. We visualized the bid, and then we wrote out our output. We created objects and wrote out our stock price data to CSV, which we downloaded. We then imported into Excel, but you could have also imported into Google Sheets directly. And then we went through a couple of steps. We took that data, and then we applied the same set of steps as suggested by Simon Beninga. Once we have our price data, we convert to returns using the log difference. Once we get the log difference, the daily returns, if you like, we can get the excess returns by subtracting away the average. And then from that, we use matrix operations available in Excel. They're exactly the same as in Google Sheets. And we got our variance covariance matrix, which we verified is exactly the same as what we had obtained in the Python Google Colab notebook.